Yep, electricity. Our demand for power is now officially outpacing economic growth, and that signals a massive transition. We are, as the International Energy Agency puts it, entering the age of electricity.
So, what does this age of electricity actually mean? Well, it's defined by an unprecedented and accelerating hunger for power. Let's break down what's really fueling this.
Okay, so you see this number, 3.6%, and you might be thinking, that doesn't sound that huge. But hold on, that's the forecast for annual growth in global electricity demand through 2030, and it's actually 50% faster than the growth we saw over the previous decade. So the key takeaway here isn't just growth, it's the acceleration. Things are speeding up, and they're speeding up fast.
And the surge isn't some abstract thing. It's being driven by the technologies that are transforming our daily lives. We're talking about the massive data centers powering AI in the cloud, the millions of new electric vehicles hitting the roads, the shift to electrify heavy industry, and, the simple, growing need for cooling and heating in a changing climate.
And get this, in the United States, just one single technology sector, data centers, is expected to account for half of all new electricity demand for the rest of this decade. I mean, that is a staggering shift in a really, really short amount of time.
So that's the demand side of the equation. But what's so fascinating is that at the exact same time, an equally powerful revolution is happening on the supply side, in how we actually generate all that new power.
And this brings us to just a massive milestone that we're about to hit. By 2030, low-emission sources, so we're talking renewables and nuclear power combined, they're on track to generate half of all the world's electricity for the first time in modern history. That's huge.
In fact, the momentum is so strong that the IEA reports that renewable generation is now overtaking coal as the dominant source of power on the planet. This isn't some far-off prediction. This is the energy transition happening in real time right in front of our eyes.
So we have this historic demand, and we have this historic growth in clean energy. This should be a perfect match, right? But there's a problem, a big one. And it's the central conflict of our story today, the great grid bottleneck.
Probably the easiest way to think about our electrical grid is like a highway system, but for electrons. It's the essential network that moves power from where it's made to where it's used. But here's the thing. Much of that highway was built for a completely different era, and right now it is facing a monumental multi-year traffic jam.
So just how big is this traffic jam? An incredible 2,500 gigawatts of power from new projects are currently stalled, just waiting to connect to the grid. It put that into perspective for you. That is more than double the entire generating capacity of the United States. All of it, just sitting on the sidelines.
These projects are all stuck in what's officially called the grid connection queue. And you can really just think of it as a massive waiting list. You've got developers with the financing, the land, the technology, everything's ready to build. But they're all stuck waiting for a permit just to plug into the system. And that's a huge drag on economic growth and on our climate goals.
And right here, this is the absolute core of the problem. It takes just 1 to 5 years to build a new solar or wind farm, but to plan, permit, and build the new high-voltage transmission lines you need to support it, well, that can take 5 to 15 years. You see the mismatch? We're building the power plants of the 21st century, but we're trying to connect them to a grid that moves at a 20th century pace.
This timeline mismatch is the heart of the bottleneck. But, and this is the good news, it's not unsolvable. There are 2 main paths forward for unlocking the whole system.
Essentially, we have 2 options. Path A is to build more. This means massive, expensive, and very slow projects to build new transmission lines. And look, this is absolutely necessary in the long run. But then there's Path B, to build smarter. This is all about using new technologies and policies to squeeze much more efficiency out of the grid we already have. It's faster, it's cheaper, and it can unlock capacity right now.
So what does building smarter even look like? Well, it involves a toolkit of so-called grid-enhancing technologies. For example, dynamic line rating uses sensors to see how much power a line can safely carry in real time. It's kind of like a traffic app finding extra capacity on a highway you didn't even know was there. Other solutions are about policy, like allowing projects to connect faster if they agree to occasionally reduce their output during peak times. These are just pragmatic, targeted upgrades. And the potential here is enormous. IEA analysis shows that by building smarter, we could free up between 1,200 and 1,600 gigawatts of capacity on our existing grids.
Now remember that global traffic jam we were talking about? That's enough to connect a huge portion of the projects currently stuck in that line, without waiting a decade for new lines to be built.
All of this brings us to the final, and really the most critical point. Unlocking this bottleneck isn't just a technical challenge. It is a race for the future.
You know, this new age of electricity, powered by AI and clean energy, it's no longer some far-off concept. It's here. The demand has arrived, the clean supply has arrived. The final, crucial piece of the puzzle is building a grid that can actually keep up with it all. So the question for all of us is this. The clean, electrified future is built, and it's waiting to be connected. Are we ready, and are we moving fast enough to build the grid that finally gets us there?